about branches, right? Specifically if statement. And the loops and the if statement are very similar to each other. If you look at the while loop example, so the question is, assuming you have some money in your bank, right? And they will give you some interest, right? They have interest rate defined. So every year your balance will increase a little bit. So the question is, how many years does it take to double your money, double your balance? So this is a typical while loop. If we change it to if, right? That's what we have learned. If balance less than 2 times initial balance, we do some work, right? Otherwise, we jump out. While loop are exactly the same. The only difference is I have another line in here says go to line 3, all right? That one becomes a while loop. If condition is true, I do the work, then go to line 3, check again, do some work, go to line 3, check again. If it's true, we do the work. If it's false, we jump out. So that's exactly what we mean by a while loop, right? What is a loop? Loop is some snake, right? Biting its tail. It's called a loop, right? It's called a loop. So this one is a loop, right? We do some work, go back, do some work, go back. It's a simple loop. So loop are exactly the same as branches, except it will jump to the condition checking, right, after finishing all the work. So this is a typical way we write a while loop, and this is the control flow. The only difference is if it's a if statement, when it's true, doing all the work, it will jump outside, right? If it's false, it will directly jump out. And if it's a while loop, right, instead of jumping out, it will go back to check the condition. The while loop will only stop when the condition is false, right? So that's the difference. And so that's basically everything you need to know about a while loop or a loop. So what we will show you today is basically some examples of a loop. So first example, right, this one, how can we compute this this number of years? First one, we need to define what is the type of each variable, right? What is the type of a balance of money in your account? What is the, is it the floating point number or is it integer, right? It should, we have 0.00, so it should be a floating point number. Rate should be a floating point number. Year should be an integer number, right? So what we can do is we can copy this part of code here and put in here. So reverse it. All right, we need to define the types, right? The type, we have a bunch of variables. No, they should be floating point numbers or double. We have initial balance. We have balance. We have the rate, right? And we have the year as an integer. And typically we need to give it an initial number. So let's say initial balance equals to balance, right? And then let's make the balance, initial balance, to be 1, and make it the reverse. So initially the balance should be equal to initial balance, and then let's make the rate to be 2%, right? It's 2 divided by 100, it's 2%. So you are getting interest rate of 2% every year, and your balance will be increased, right, by the interest rate. And then for every year, you increment the year. And let's give it the year initial number to be 0, right? And we could see out the year. And when we run it, we will get a 36, right? After 36 years, your balance will double. So this is the typical while loop, right? You can read it as an if, right? If balance is less than double the balance, you do the work, then go back to your while loop, then check again. If it's true, we do the work again. If it's false, we jump out, right? It will jump out. The while loop, this part will be false when balance is greater than or equal to double your initial balance. So this is the way we do it, and a few types. And the next thing we typically say is, we normally have the confusion. Should the year start at 1 or start with 0? So that will be some of the problems. As you can see here, I start with 0, right? Indeed, it should be started with 1. So another way to check it is, okay, assuming I make that mistake and make it 1. What we can do is, okay, we can test it. How can we test it? Using some simple cases. For example, what if I increase the interest rate to 100%, right? Every year it gives me 100% of your balance to your account as an interest. Then your output should be 1, right? After 1 year, your balance is doubled, right? You should use this kind of simple examples to test. And if your output is 2, you know, okay, there is something wrong with it, with your initial number. So test this one with some simple case so that you will get the correct initial values. That's something people might have errors. It's called off by 1, right? Sometimes you start with 0, sometimes you start with 1. You will have these problems in the future. And the next, you should also consider what's the testing here, right? Should it be balanced less than double or less than equal to double? So that's also something you need to consider. And use some test case so that you will see the things. So if, for instance, if it's less than equal to, right? If it's less than equal to, wait a minute, let me make it 100% so that you will be able to distinguish the difference. The output will becomes 2, right? Because when this one becomes false, it should be greater than double. So be careful about less than equal to or less than, and also the initial values. It will round off by 1. All right, so any questions on it? Any questions on this example? And the running off by 1 error, right? There are 2 cases you will get running off by 1. One is the starting year. Another one is your condition, whether then it's less than or less than equal to. You will have different answer. No? Let's continue. So as you can see, a loop will stop when the condition is false, right? Sometimes people will write infinite loop, a loop that never ends. For instance, this one, it is because of some errors, right? If you read it, while year less than equal to 20, we create some interest and we increase your balance, right? That's the thing. The thing is, you never change the year, right? In your body, in your loop body. So no matter how many times you loop, your year will be 1. You will never jump out of your loop. But if you look back in here, right? Because your balance is increasing every loop, at some time, this condition will be false. You can jump out. So remember to do that in your loop. So the question is, how can we stop it? How can we, if we write a program like this, right? How can we kill the program? We kill it using Control and C. Let's assume it in here, right? This is the program I write while year less than 20, but I never updated the year, right? So we can compile it and run it. It's indeed running. It's not waiting for my input. It's running. It's an infinite loop, and we need to kill it by Control and C. As you can see, Control C here. Control and C, it will run. It will stop your program. But if you are in an IDE, it will be much easier. There, when you run it, there will be a stop button, and you just click on the button. But if you are in terminal using Control plus C, all right. And what is the simplest way to write an infinite loop? What's the easiest way to write an infinite loop? Let your, condition of true, right? We said it is exactly the same as an condition, right? If true, we know this one is always true, right? Make it while true, it's an infinite loop. You do nothing while true, do nothing, or you do something else. No matter what you're doing here, right? Just see out test infinity /n, right? It can still run. Wait, there's no output. Yeah, it's here, right? It's almost killing my program. I'm killing my machine. All right, I need to kill it. It's an infinite loop, right? While true. Or sometimes people would prefer to write while one, right? It's still an infinite loop. You do cout, check, is the condition true or false? If it's true, cout. If it's true, cout. If it's true, cout. Because it's always true, so it will do infinite time of the loop. So it is useful sometimes, right? Especially when you are designing a server. If in the server, you don't want to kill your program, you want it always running, waiting for your user to give you some queries, do some operations, you can respond. And at that time, you are indeed creating an infinite loop. You're always waiting for the user to give you some input. All right. Next one we want to talk about is called sentinels. So let's assume you want to read, right, a sequence of input values, but you don't know how many of them. User will not tell you I'm trying to, for example, a query, right? A query in a text box. You will never know the user will input how many numbers, how many queries will be there. So you just keep reading, and you need to have some method to terminate the input, right? Otherwise, you are always waiting. So a number, for example, is used to signal the termination is called sentinel. And it only works only when the input has some restrictions. For example, we use the example, assuming the user will input a sequence of salaries, and we want to compute the sum of the sequence of salaries. Because the salaries are always positive, right? We could use some number like negative, use that as a sentinel. Here is an example. We are, for example, as a user, right? We are asking to compute we could first input, for example, 10, then 20, then 30, then 1, then -1, right? This is our input, user input. For example, 10, 20, 30, 1, the -1, right? This -1 is to specify, okay, the user is to use it to specify, I'm done with typing. I'm done with input. You can start computing. This one we call it sentinel. And in your program, how can we write it? We are checking is the salary equal to -1 or not. We first check is this one a -1 or not. And each time we are giving the user a hint. Okay, -1 means a finish. It doesn't mean a valid salary. Okay, so we see in a salary in our while loop, right? As long as your salary is not -1, we will continue the loop. And we will do it over and over and over again until our user input a -1. We will stop the while loop and jump out to compute the average salary. And as you can see in here, we also have a checking because when the user input a -1, it's not a salary you need to compute. It's a sentinel. So we will skip the adding. We will not add it to the sum, right? We will not add it to sum, but we use an if statement to skip the put it, sum it into the sum of the -1 and then jump out. Right? Any questions on it? No? So the user is basically could enter any number of salaries, right? It don't have to specify how many of them. So this one, we will call it Sentinel. And another part of Sentinel is called, there are some keys, combined keys in your keyboard that could also specify that that's the end of your input. So in Windows, it's Control+Z. In Mac or Linux, it's Control+D. So let's do it. Assuming we want to compute the highest value of a sequence of integer numbers, right? We want to compute the highest value of a sequence of integer numbers. First, we didn't specify how many integers, right? We didn't specify how many integers. And we didn't say a number, for example, -1. It's valid, right? We didn't say it should be positive. So we cannot use -1 as a sentinel. So for instance, if it's input -10, -1, 10, 1, right? The highest or largest number should be 10. That's our goal. Okay, so the question is, how can we do that? The key idea is we read number by number, right? If the first number get in, if this is the only number, we set this one as the highest one, right? If we already have a bunch of number and we know the highest of the previous sequence, whenever we get in the next one, we compare the next integer with your previous highest one. If your current number is higher than the previous highest one, you set highest as the new input, right? Otherwise, keep your highest to be the highest of your previous one. So that's the key idea. How can we implement it? We implement in this way. We first see in, and if there's only one number, right? If there's only one number in here, let me just highlight this one. If there's only one number, we're seeing this number. And if we seeing this number, because there's only one number, we know the highest number is the only number, right? Otherwise, if we already have the highest of the previous numbers, when we're seeing the next number, whenever we're seeing the next number, we compare the next number with the previous highest ones. If the next number is larger than the previous highest one, we know our new input is the highest, right? And as you can see here, we use a cin inside our while loop. Similarly, we use cin inside our if statement, right? We use this one. And when we click on Control+D, this one will return a bad state or it will fail, right? We see into a number will fail and we will jump out of the while loop. If it's correctly input into your number, it will be a true. So let me implement this one. So let me see if I can copy. There's too many numbers in here. Let me copy this one. So first one, we could say, what's your next input, right? Each time you need to see in your next input. And also you need your highest one. So let me just assume they have more than one input. So we could input your next, and you could assign highest to be your current next. So if there's only one element, we are done, right? If there's only one element, we are done. Then what we need to do is, if there's more element, we need to see in to our next. What is our next input, right? If we get a next input, we also have the highest for the previous sequence. Then we compare our next with the highest of the previous sequence, right? If the highest of the previous sequence is smaller than current next, I will assign update my highest to be my current next. And then I could output my highest one, right? So that's basically the step. Let me run it, right? If my input is 1, 2, 3, and the control plus D, that's the end, right? It says the highest one is 3. What we can do is we could also do debugging, right? We could debug, put a breakpoint in here. Maybe not here, maybe here. After running this higher, maybe, yeah, maybe line 19. Okay, let me do this one. All right, let me first do input 10. Wait, is it running? Oh, waiting for me to enter another one, 20. Okay, when I'm here, right, the highest one, I don't know if you guys can see it, highest one in here is 10. Highest one, current highest one is 10, which is the highest one before my next, right? And my next input is 20, because 20 is greater than 10. So after running this line, highest and the next will be updated to 20. 20 is current highest, right? Before my next input. Next, I could enter my next input, which is waiting for me to enter, for instance, 30. I run to here, next one, my input is 30. Highest one is the highest of the previous two, right, which is 20. If 30 is larger than the previous highest, I will update my highest to be 30, right? Otherwise, if my input is 15, right, then my next input is 15, and my previous highest before 15 is 30. This if statement is not true, so I will skip this one. I will keep the highest, and I will skip the line 19, and I will waiting for my next input. My next input could be 40, right? And then my next input is 40, and my previous highest is 30, right? Previous highest before 40, the highest is 30. In this way, you are remembering the highest, which is the highest before my current input, and compare it with my current input, then updating the highest. So that's the basic way you could debug your code and to see if this one is correct. All right. Any questions on it? The thing you need to remember is cin will fail when you click on Control plus D. So you could use a while loop to do that. So in previous year, we have project assignment, right? Project assignment, the first question is find out the second highest one. This is finding the highest one, right? Our first assignment, the first question is finding the second highest one. I will not show it here. Go back and think about how to write it, but it will be very similar to this one. Find out the second highest one. All right. Let me skip this part. All right, so we have already know about for a while loop, right? And we know if somehow we forget to update this I, we will have an infinite loop, right? If we forget updating this I, we will have an infinite loop. And also, this is a very common form, right? First one, we have initialization of a number, and then we have a condition to check if this one reached the end or not. And inside of the body, we need to update this number each time so that at some time this while loop will fail, right? This while loop will be false and jump out. So this is a very common one. So we introduced a special form called a for loop, right? A for loop are exactly the same as this while loop. We put a initialization here, then a semicolon, then a checking. If this one reached the end, then a semicolon, then updating this index or updating this number. All right, this is a common way to write a for loop. But indeed, a for loop is very simple, right? We don't have to say the first one has to be I, second one has to be I, last one has to be I. No, there has to be statement, initialization, condition, update. So any form could be working. Example, it could be rate assigned to 6 as an initialization, month minus could be the condition, and the cout balance could be your updating statement. It's totally valid. It's valid in your compiler. It can run, but I would not suggest you do this in this way. We call it bad style. We call it bad style. It's really bad because you are putting some of the unrelated things together, right? Let me run it. So that you know this one can still run. Let me run it. All right, let me give an x, int x, std cout input, std cin x. All right, I need another sum equal to 0. And I will output a sum, right? This is still a valid while a for loop. Let me run it. It built successfully. It see out the inputs, right? This line, see out the inputs. Then it will do a checking your condition expression. Let me input 10, right? It is indeed doing sum equal to sum plus x. Then it's waiting for me to do another input. Let me do, 20, 30, 40. And in order to make cin fail, I need to enter control plus D, right? Control plus D, control plus D, right? At the end, it outputs the sum. As you can see, these one are valid for loop, but it's not suggested writing this way. If you need this using a while loop, right? How can we convert it into while loop? It is exactly the same as we need the first line. It is exactly the same as another while loop, which is in this way. Right. So the for loop and the while loop are exactly the same. This is the while loop part. This is the for loop part, right? First part of for loop is initialization. It will initialize only once. As you can see, line is 16, only once. Then your condition, std cin x, std cin x, right? It's the condition. And the update sum equal to sum plus x, sum equal to sum plus x. This is the body, right? Or this is the update statement. It will be executed every iteration, right? So the second part and the third part of for loop will do every time. But first initialization will be only once. So that's the for loop part. It could also be, as you can see, this is initialization, right? Initialization could also be empty. Let's do it. It could also be empty, something like that. You could also run it. 10, 20, 30. Right? It will output something. The last part could also be empty. We could write sum plus x. Right? Let's run it. 10, 20, 30, Command D, right? The middle part, let's try it, can it be empty? Yeah, it can still be empty, but it will never end. And after maybe later, we will learn how to break out of the for loop, but it's still valid. It's still working. It's running, all right? Which means you could write your for loop like this. It's crazy, right? Never writing this way. But sometimes skipping the initialization part is okay. Sometimes, all right? Writing this way, sometimes okay. You are skipping the initialization part. But if you trying to do this way, maybe it's better to write a while loop, right? While loop would be better. So we said use the for loops only for intended purpose only. What's intended purpose? This is a good example, right? Initialization I less than some bound plus I, right? This is a very common way to write a for loop. It's a very good way to write it. You can skip the content for now. This means a string comparison. It's a string, right? You are trying to loop, iterate from the first character to the end of the character in a string. But there's a typically sometimes bad part is you are modifying the index inside your body. As you can see, here is a plus I, here is a plus I, right? Here's a plus I, here's a plus I. Try to avoid it that way. Only update it in one place. You will see why that's the case. Okay, let's use this one as an example. This one says, do not use not equal to test the end. We typically use less than or greater than, right? Because not equal, sometimes you will fail to get this one. Let's see, this one is a floating point number because floating point number comparison is sometimes tricky, right? Even if it's an integer, let's say, even if this one is an integer, let's see how it will make it not working is, for instance, let's make a rate equals to, it doesn't matter, it has the initialization. And because we make it this way, so let's call it plus rate. All right, this one is rate from 5. As long as it's not 10, we will do some work, right? Each time we will increment the rate. And the for loop ends only when rate equals to 10, right? Because your code is so long, sometimes here is a long code. And in some place, you might say, okay, rate becomes rate plus 1, right? At some place. And you would need to see how it works, right? Let's see out. Let's print this one so that you will be able to see it. Let's run it here. Run it. Right. So yeah, first output 6. Next, let me run it. Next output 8, right? Next output 10. Next output 12. What's happening? When it equals to 10, it is supposed to jump out of your for loop, right? What's the problem here? Because your for loop, there's an inherent updating in here, right? At line 17, your rate is 10, but next the rate becomes 11. Then it compares with 10. It will jump out. It won't jump out, right? If I convert it into a while loop, it's like this. Rate initially is 5, while rate not equal to 10, right? We do some work. And we said updating your rate. Okay, wait. Updating your rate is at the end of your while loop, right? You have some long code and you have your rate plus 1. These two parts are exactly the same. All right. Your updating is at the end of your loop. It is at the end of your loop. And you are incrementing rate, right? Then you incrementing rate, right? You are incrementing rate twice. So rate can only be some odd number. So rate will never be 10 when you are in this line, right? First one is 5. 5 now equal to 10. Plus 1, 6. Plus 1, 7. 7 not equal to 10. Plus 1, 8. Plus 1, 9. 9 not equal to 10. Plus 1, 10. Plus 1, 11. Not equal to 10. right? It will keep running. It's an infinite loop, actually. Questions on this? No, right? So if you write in a while loop, it's easy to see, right? But if you write in a for loop, it's not that easy to discover these errors. So yeah, let me continue. So it's preferred not to use this symbol, right? Not equal or equal. It's preferred to use less than, greater than, that kind of symbol. So as an exercise, do it offline. I will just do the first one, right? How many iterations does it run? The first number I equal to a, right? Then a plus 1, a plus 2. What is the largest number of I? B minus 1, right? It should be B minus 1. So the total number of iteration is B minus A, right? Total number of iteration is B minus A. So if it's from 0 to 10, it's 10 rounds, not 9 rounds. It's 10 rounds, right? It's 0 to 9, 10 rounds of your iteration. All right, do it offline. And you can print out, right? If, for instance, if you're not sure about that, print out. So you will be able to see how many iterations. Let me use a tab so you can easily see. Right? From 0 to 9, it's 10 rounds, 10 iterations. It's very important to note that. All right, this one is also easy. Print bar, then equal, then bar, then equal, right? And also rewrite it in a while loop. We have done it multiple times. You should be able to rewrite it in a while loop, right? Converting while loop to for loop to while loop. Do that offline. A real exercise, write a program that tests if a number is a prime number. To test if a number is a prime number or not, right? Let's just assume the number you input is greater than 3. That will be easy to identify, right? For instance, if a number, if your input is a, wait a minute, let's just see, don't use any hint. Input some number, right? We need to see out is this number a prime or not. So we use a Boolean variable called prime or called p or anything could work. Invalid operand, all right, invalid operand. Then we could output, right? If prime is true, we could output a prime, right? Otherwise, we output not a prime. We could do that, right? That's something we can do. How can we test if a number is a prime or not? If I give you a number 10, right? If I give you a number 10, we could test from 2, 3 until 9, right? Divide 10 by 2. What's the remainder? Remainder 0. Oh, it's not a prime, right? Divide 10 by 3. Remainder is 1, right? Something like that. Divide 10 by 9. Remainder is 1, right? As long as we find any place, the remainder is 0, it should not be a prime number, right? So that's what we are trying to implement. For instance, we could have a loop starting from 2 until number minus 1, no, number, right? And we can increment I, right? These are the numbers we're trying to test. Can number divide by I, right? What's the remainder of number mod I? If this guy is 0, it means it's not a prime, right? So if this one, such an I exists, prime should be false, right? That's the code. And indeed, we need to give an initial value to prime. We could assume this number is a prime number, right? We assume any number is a prime number. Only after we find out some I that can divide it, we know this one is not a prime number, right? Let's assume number is greater than equal to 3, right? Let's do that. Yeah, question. Pardon?
9 is not.
9 is not a prime number. Yeah, it's true. 9 is not a prime number. Let's test that. All right, let's test that. How about given 9, right? Not a prime number, right? How about a 7? A prime number, right? 9 is not a prime number. That's correct. When I becomes 3, 9 mod 3 is 0. So prime is false, right? 9 is not a prime number. It's correct. So that's how we test if a number is a prime number or not, right? The easiest way. Indeed, we don't need to do that. We don't need to test so many numbers, right? The largest number we need to test is actually square root of number, right? But anyway, let's skip that. You guys can check why it should be square root of number. But because machines are so fast, we don't care. Let it run more times. It doesn't matter, right? It's the easiest way to test if a number is a prime. All right, let me change the problem a little bit. Print out all the prime numbers between 3 to 100, right? Print out all the prime numbers between 3 and 100. Here we use a for loop. Now we could use 2 for loops, nested for loops. We talk about a nested if statement, right? We could also use a nested for loops for number starting from 3 less than 100. Wait a minute. Then we test it, right? For any number, we test if this one is a prime or not. So what's the problem in this code? There is a problem in this code. And let me see out if prime. See out this number separated by a tab key. What's the problem between this code? In this code? What will be the output? Yeah, there will be only one prime number. When you run it, the output is only 3. Let me see. Wait, it's not stopping? Where's the problem? Let me check that. For numbers, oh wait, it's waiting for me to input. Forget to remove this line. Yeah, there will only be outputting 3. Because when it's 3, prime is true, right? We will output 3. But when it becomes 4, prime will become false. And the prime will never change back to true again. Inside of this part of code, prime is only assigned to false. It is never assigned to true. Right? If we look at the loop, you go many loops. This is the only place prime is assigned. Right? Prime will only be false. It will never be true. So what's the problem? The problem is you should assign true. You should assume the number is prime for every number, right? You should put a line in here. You should assume the number giving you is a prime number, then if you find an I that making sure prime this number is not a prime, you assign a false to it. When it goes to another number, you initialize everything, right? You initialize the prime, you assign to 2, then you do a false. Go over this example, and you will be able to see the difference. And it will output all the prime numbers, right? 3, 5, 7, 11, 13, 17, 19, 23, right? That's the output. So any questions on it? Pardon?
Was the set I read. Times true.
Which line? Which line?
I don't test the prime true in this code, and after that I write return.
Return to where? It's a main function. There's no return. Either
Under the
this line?
Yeah.
You want the return? Return means jumping out of your main function. So there will be only 3 printed, and there will be nothing. 3 printed, then nothing. Because when 4 comes in, when number equals to 4, and then 4 mod 2 equal to 0, then it will return. Return means ending the whole program. Ending the whole program. Yeah, so that's the difference. All right, so let me remove this line. Right, any other questions? No? All right, we will have another example. Compute the greatest common divisor, GCD, of 2 numbers, right? If it's, for example, if it's 12 and 18, the GCD is 6. If it's 10 and 8, GCD is 2. If it's 5 and 3, GCD is 1, right? This is the greatest common divisor. 12 divided by 6, 18 divided by 6, right? 10 divided by 2, 8 divided by 2. These are the greatest common divisor. This is the largest number which can perfectly divide 2 integers. There are a smart way and also a slow way. Let's do the slow way because that will be easy to implement. First one, we have 2 numbers, right? 2 numbers. And let's see number 1 and number 2. And next we need to compute the greatest common divisor. So let me erase this part. So first argument is that greatest common divisor should be less than the largest and smallest number of these 2 numbers, right? If it's 18 and 12, the GCD should be smaller than 12, right? So we could first find out the smaller number of these 2. Let's do integer smaller one equals to, if number 1 is less than number 2, answer is number 1, otherwise the number is number 2, right? Can you understand this line? If number 1 is less than number 2, smaller equal to number 1, otherwise smaller equal to number 2. This is the smaller number between number 1 and number 2. And in our for loop, because it's the largest one, so what we can do is we will iterate from the largest one, right? Starting from the largest one, then as long as it's greater than 0, it's fine. And each time we are decrementing I, right? We are trying to find out the largest one. So we decrement the I equal to I minus 1 each round. And what's the condition? The condition would be num1 mod I equal to 0, right? And number 2 mod I equal to 0. That is the common divisor, right? What we can do is we can see out this I. Let's use this one. Right, what we can do is type in two numbers. It's outputting a 4, right? Indeed, it's outputting all the common divisors. The first one is the greatest common divisor, right? How can we only outputting the first one? We will learn something called a break, which will break this outside. But let me show you another way. Another way is defining something called a flag. We could create a Boolean type. For example, is it done, right? We first make it not done, assuming it's not done. And whenever we find out the first one, we will assign done to be true. And if done is true, means we already print out the common divisor, and we can stop the for loop. How can we do that? Not done and I greater than 1, right? The for loop will only continue when not done. When you haven't output anything, you will continue the loop. Any place you have output 1 common divisor, you are done. You are done. When go to the condition here, it's a false. It's false, you will jump out of your for loop, right? If you run it again, for instance, 12 and 16, you will only output 4. Try to understand this one. You will be able to have better understanding what is the condition of a for loop, right? And we will talk about other part. We will come back to this one when we talk about break. All right, so a simpler one, this one you don't have to fully understand or you don't need to use it. Indeed, I maybe in the maybe past many years, I haven't used the do while loop because this one are exactly the same as while loop, only by one difference is you will execute the body at least once. Right? Instead of checking while first, you do the body first, then check the while. So if you look at the flowchart, you will ask the user to see in first, then check if x is less than 0. If it's a while loop, while is above, you will first check x. Right? You will not do the body if the x is greater than 0. So that's the difference. So do while is you will execute the body at least once. You will do it first, then check. Do it once, check. While is check, do, right? That's the inverse part. And the more important thing is the while loop and the for loop, right? Do while loop, not that important. All right, let's talk about jump statement, right? How can we do jump out of the for loop? For instance, in this one, right? Instead of doing a condition like this, right? In this one, this is the original one. We will output all the common divisors, right? What if we only want 1, right? What if we only want 1? We can create a break here. Break means you are done with your for loop. You will jump out of the whole for loop. So if we put a break here, when you run it, you will get a 4, right? So that's the usage of a break. Jump out of the whole for loop, ending the for loop. Now you are done with your for loop. So that's the usage of a break. Break and continue are different. Continue means skip the rest of the current loop. Let me show you the case. This is the break, right? If n equals to 3, we jump out of the for loop in this example. It will output 10, 9, 8, 7, 6, 5, 4. Then when it becomes 3, countdown aborted, then jump out. So break can be also used for sentinels, right? Remember, in here, we are using the infinite loop while true, right? wait, it will infinitely running. And when your salary is -1, you do a break. You jump out of your current loop. It is used as a break, right? You jump out of your current loop. So this one is for continue. Continue is slightly different. Let me show you continue. So right here. Wait. All right. So it says it starts from 10, and each time it -1. So it's 10, 9, 8, 7, right? And when it becomes 5, it will continue. It will skip all the remaining code when n equal to 5. When you run it, you will be able to see it is 10, 9, 8, 7, 6, right? Then a 4. Because when n equal to 5, you are skip your current iteration. But you will continue with 4, right? You will go on with next iteration. If I make it a break here, right? What's the output? If I change it from continue to break, what's the output? It ends with a 6, right? It ends with a 6. Yeah. And you can also check that by creating your breakpoints, right? You can put a breakpoint here. You ask your program to run to line 15. Until line 15, you already printed 10, 9, 8, 7, 6. And at this iteration, n equal to 5, n equal to 5. That's why you can get into line 15, right? When you click on execute the next line, typically it jumps to line 16, right? But because it's a continue, it will automatically jump to line 13, go back to the first part of your for loop, right? So that's the continue. You are skipping the remaining part of your current iteration, jump back to your for loop. You can use your debugging tool to show you the execution order, all right? Any questions? Yeah.
If I use a for loop in another for loop,
okay.
if I use a break,
yeah.
It jump out all the for loops?
No. It's only the loop that's inside your. What should I say? It should be your innerst loop. Yeah. It depends on which for loop it's in, right? So we could have another one for int k equals to 0. K is less than 3 plus k, right? We could have another one. Wait a minute. Let's put it here, right? So if it's a loop inside another loop, we could run it. I should delete this one. Let me rerun it. Yeah. As you can see, it will output 3 times, but each run there will be a 5 skipped, right? So this continue only work for the current for loop, not the outside of your for loop, right? If it's a break, you will see the similar things. It has 3 rounds, right? Only breaks the current for loop. So that's the break and continue. So the last part is the goto. So do not use goto in your project. It's very old. And let's show you how goto works. It's exactly the same as we introduced in the beginning of the class. You can define a label called my label. And someplace you can say go to my label, right? And this after this line, it will go to this part. You are using if statement as a loop, right? It is exactly the same as a do while loop. Do some work while n greater than 0, right? These two are exactly the same. This is the usage of goto. You will see in very old project they use goto, but do not use it in your code. Never use it in your project. All right. Also, nowadays people kind of remove this one because it's making your code very complex and very hard to debug, very hard to read. So just understand it, but don't use it. So that's goto. All right. So any questions so far about the loops? Because loops are so similar to if-else statement, right? I will quickly go over this one and show you some examples about loops. Yeah, question.
My label go first, and then we'll do the go to. And if I mean, if I change
change the order
after go to, if doesn't work.
Yeah, I believe so. Maybe yes, maybe no. It really depends. Let me try it. I haven't defined that way because I almost didn't use it for many years of this one. Let me see. That's your question, right? I define my label after it. Wait a minute. Then that will be not useful. All right, put my label in here. If n is 10 and n is greater than 0, then I go to my label. So I will only output lift off. Let me see if it can work. Yeah, it can work, but it outputs 10. It outputs 10 in here, right? If it's 0, it outputs 0 and a -1. Yeah, it means the label could be defined any place. You don't have to be before that, right? If it's defined after it, it can still work. It output 10. Then if n greater than 0, n is 9, right? I jump to my label in here and output lift off. So label could be defined anywhere, but don't use it. Don't use it. Don't use goto, right? Let me go back to what I have. All right. So next is the most important thing, functions. I will start a little bit about functions so that you can go back and preview the remaining slides. So functions, we use them as a black box. We use black box because we don't care how these functions are implemented, right? You don't need to care how square root is implemented, but you still use it. And you don't care how the functions are getting the whole line from stream, you don't care. So that's we call a black box. You only need to know what's the input and what's the output, right? So square root is, you know, your input is a floating point number, your output is a square root. So like this, you think of it as a black box, right? Input is x, output will give you square root of x. And another thing is you use function call. You call a function like this, right? Y assigned to be square root of x. You are calling the function square root of, and give it first argument or parameter. Give it argument x, and your function will get x and will output the y you need. And also it could be two arguments, right? X and y. It don't have to be one. It could be two arguments. It could be an expression, right? B squared minus 4ac. You could call your function like square root of b squared minus 4ac, right? So that's the way you can use your functions. So this is the way we use function, right? First, in our main function, we first compute b squared minus 4ac, get the result, then send it to your square root. And your square root will compute the square root and return the result to whoever is calling your program, and return it. You can use it, right? So let's write one simple example. Assuming we have the floating point number n equals to 4.0, right? And we could simply see out square root of n. Yeah, right. This is the way we call a function. What we can do is we can define a function, right? What we need to learn is how can we define a function. First one is our return type. How can we return? We need to write a function that's returning a floating point, similar to the main function, right? Main function return an integer. We need to write a function that return a floating point. For example, my square root, right? And also you need to specify what is your input. What do you need to take, right? And also the type of it. For example, I need to take a floating point number, and you give it a name, any name would work. And also you need to define the body of your functions, right? This is a function. You could return something, return a floating point number, right? And for example, you can call another function to return your function, and you call this one my square root, all right? So when you run it, it's doing similar things, right? In your main function, you are calling your function called my square root. You give it a number n, 3.0. Then this function will call that function, right? The my square root. And the my square root will take a floating point number and return a floating point number. And it will assign 3.0 to a number, to your number. And then it calls a function called square root. And it will call another library, square root, then return the number, then return the number to the main function and see out, right? And what you want to see is you can use your breakpoints to see how it is executed. First one, you go to this line, right? N equal to 3.0. As we said, main function is always the entry for your program, right? So you will enter your main function and then define a variable n equal to 3.0, then call my square root, this function, right? And if you want to debug it, you need to click on something called step into your function. And you can step into it. You will see, okay, now I am inside this function, right? You are jumping, your control flow jumps from your main function to here. And if you look at here, your number now is 3, right? You are actually assigning n to your number. And then you are calling another function called a square root and then use it to return, right? Use it to return it. And yeah, and the output of your function will be put in here and printed, right? It will be printed. So that's the basic flow. So what's the benefit of defining your own version, right? So for instance, what you can do is differently. Let me stop this one. And let me see in n. Seeing n, you do this, right? If I give a -1, you get an n. Some people don't understand what is an n, right? So what can we do is, okay, how about we define our own square root function? And what we can do is we can add in some useful information here, right? If it's less than 0, we just output negative number provided, right? We could give it some information like that. And then when you run it, you get some useful information, right? Negative number provided. And then, but you're still doing the square root. There are some ways, for instance, you could return 0 instead, right? And otherwise, you are returning the square root, right? This is your version of square root. If it's less than 1, you could say, let me try it. Right? If it's negative provided, I always provide 0, right? Otherwise, it will provide square root. So that's how we define and use a function. And typically, people will put a comment in here to explain what's the usage or what's the behavior of your functions. You could say return 0 if negative number is provided, right? Otherwise, return square root of number. So people don't need to read what's inside your code. All they need to read is your explanation of your functions. And when they read it, they know how to use it, right? So that's the basic usage of your function definition and also calling a function. That's very important. And the reason we do that is we want to encapsulate some of the code that will just in one functions, right? For instance, in this one, right? Instead of checking your number less than 0 outside of your square root function, we can put them inside your square root function. So the code will be cleaner in your main function. In your main function, the only thing you know is cin and do the square root and c out, right? All the other checking behaviors will be put in another function, right? We could also do 2 arguments, right? We said power. How can we compute the power? Assuming we're seeing a floating point n and an integer power, right? We could see a number and a number. Then we do my version of power, right? N to the power of p. Let's rename it to my power. A floating point number and an integer number power. And we say we are returning number to the power of power, right? How can we implement that? How can we implement number to the power of power without using the C math? Without using it, how can we implement it? We first define our result to be 1.0, right? Then we do a for loop. Integer I equal to 0, I less than power plus I. Result equals result times number. At the end, return result, right? This is the for loop we have learned. It will iterate power times. Each time it will multiply your result with a number, right? So that is number to the power of power. So that way you are defining 2 arguments, right? And let's see how it works. My power and p, right? This is how we call this function. When we call this function, we will get into it and we can run it. For instance, if we want 2 to the power of 3, right, we get 8, right? If we want 3 to the power of 5, right, we get some number. So that is the way we define functions. Return type and also 2 arguments. The names doesn't matter, right? It is a number or n, doesn't matter. It could be exactly the same as this one because they are local. Because they are local here, it could be n, right? Because the n and the power are local inside your functions. It could be exactly the same name as the variables in your main function. They will not conflict with each other. And you could, but we would suggest you give a meaningful name. For instance, we typically call it base, right? We could typically call it base to the power of power so that people know what does it mean, right? Base to the power of power. And when we run it, it's exactly the same. And for functions, like I said, the only thing you need to know is the explain it. Explain it. If you explain it in this way, people know what is my power, right? It don't have to be this name. It could be A, B, C, D, right? It could be A, B, C, D. Yeah. Your function name could be any name. Could be any name, as long as you have the explanation, right? But it is suggested, give it a meaningful name, like the my power, right? It could be also power, because we are not including the C math library. We will not have a conflict. We just call it power. that will be work, right? There will be no conflicts. Yeah, 4 to the power of 5. So that's the example in here, right? This is the for loop we have learned. With for loop and functions, you will be able to write almost any functions, right? Any program you can write using loops and functions. Any questions so far? Yes.
The function of the float before the part section.
This one?
Yeah.
Defining the return type. You want to return something, right? This one.
That is already defined as floats.
Yeah, but all right, let me do it in this way. How about I put an int? It can still work. I can still return a floating point number. It will do the conversion. 2 to the power of 3, get an 8, right? This one only specifies the return type. Whatever the result is, it will convert it into floating point number. But if somehow, for instance, if power is negative, you want to say, okay, how about I return a string, right? Negative power provided. It will have some errors because your return type cannot be string. Your return type should be a floating point number. You have to strictly follow that, right? So that's the return type. These are the type of your input. The float is the type of your return value. Yes, question. Yeah. 讲中文可以。Which one? This one? Definition? You don't need to define it. You can give it any name. It's just some names. We will talk more details about that. Yeah, it could be int b, int p. Just the only thing you need to define is how many arguments you need and what are the types. That's the only thing. All right. Yeah, question.
我在一个自己定的函数里只能有一种结果的。
Yeah. Yeah. Your return type is strictly constrained to float. If it's float, everything should be float. You cannot return different types. But in the future, we know how to construct different types together. So your return type will no longer be a simple type, but some constructed type, like a struct class. You can return a class. You can return a very complex things.